Hey guys, welcome back. Whenever we want to work with large number of data values, we need to use much number of different variables. As the number of variables are increasing, the complexity of the program also increases, and programmer get confused with the variable names. There may be a situation in which we need to work with large number of similar data values. To make this work more easy, programming language provide a concept called array. That is what we are going to discuss in this lecture. An array is a variable which can store multiple values of same data type at a time, and it shares common name. In addition, this is most efficient data structure for storing and accessing a sequence of objects. Array occupies contiguous memory locations. Moreover, array size is fixed and cannot be altered dynamically. To understand the concept of array, I will give simple example. I am just declaring three int variable called A, B and C. If compiler executes this line, it allocates 4 bytes of memory with name A, and compiler will allocate another 4 bytes of memory with name B and more 4 bytes with name C. These three memory locations are may be in sequence or may not be in sequence. Here these individual variables can store only one value at a time. Imagine that compiler memory looks like this. Here, assume that each box is 4 bytes of memory. If we assign A equal to 5 and B equal to 10 and C equal to 20, these values will be inserted in memory locations like this. Now consider array declaration. Int marks of 6. Here compiler allocates total 6 into 4 byte each integer, which is 24 byte of continuous memory location with the same name called as marks, but allows to store 6 different integer values at a time. Okay, I will represent this memory location in diagram. It will allocate 6 continuous memory location in computed memory, and mark will be pointed to first memory location of the array. This can hold integer type of data because we declare this as int type of array. So it will hold only int type of data, and here we will store only 6 int values. Let's take 90, 92, 86, 91, 85, 88. While the complete set of values is referred to as an array, the individual values are called elements. But how can we refer or access the individual element is a big question, right? Compiler not only allocate memory but also assign a numerical value to each individual elements of an array. This numerical value is called as index. Typically, we need to use index to access the array elements. Note that index always starts with 0, not 1. So this is the index of 0, this is index 1, this is 2, 3, 4 and 5. So if you want to access fifth element from this array, you have to use index this. So mark of 4, which means it refers this element from the array. So it will return 85. And one more thing, if you try to hold another type of data, it will throw compile time error, because an array is a group of similar data type items. And another thing, the size of an int is really compiler dependent. Back in days when processor were 16-bit, an int value was 2 bytes. Nowadays it's most often 4 bytes on 32-bit as well as 64-bit systems. Okay, now imagine that if 90 is stored at the memory address 5500, then 92 will be stored at 5504 and 3 will be stored at 5508 and so on, because every int variable occupies 4 bytes of memory. This is the way array will work in any programming language. The thumb rule while we choosing data structure is always we have to consider about big O. I am not talking about only array, I mean all the data structure like linked list, stack and queue also. In general, what and all we will do with collection of data? We will access the element from the collection, we will add the element, we will delete some elements from the collection, and we will find the elements from the collection of data, right? So we have to calculate the complexity for these operations for all the data structures. By this way, we can identify which data structure is suitable for a given requirement. Let's calculate the complexity for these operations for array. So for this array, what is the complexity to access the element? If you want to access first element, you can directly use the index of an array, that is markup 0. If you want to access fourth element, you can access it by markup 3. Right, so its complexity is 1, that is O of 1. And the next operation is addition. While we add the element in array, if we add new element as last element of an array, it will take one time. But if you want to add the element middle of an array, what you will do? Just take that, you are going to add the element here. Then you have to shift these elements to next location. Then you need to add this element here. So this shift cost is n times, because you don't know how many elements will be there after write this. So you have to shift it for n times. That means complexity for the addition is O of n. And the next operation is deletion. It's similar to addition. If you want to delete the element at last, complexity will be 1. But if it is middle, then you have to delete the element first, then you have to shift it for n times. So the complexity of the deletion is O of n. And the last one is finding the element from an array. If you want to find 80h from this array, then you have to travel one by one and finally you will get the value. So you have to travel for n times. So the complexity for the search operation for an array is O of n.